So good evening all of you. Today I'll discuss how to derive the ground state term symbol for an atom or an ion. So ground state term symbol is an expression of total angular momentum of an atom or ion in its ground state. It gives us an idea of the extent of RS coupling or spin orbit coupling in the atom or ion. It also helps us determining the nature of electron transfer, giving rise to various spectrum. The ground state term symbol is generally expressed 2s plus 1 Lj, where 2s plus 1 is the spin multiplicity, L is the total angular momentum, and J is the Russell-Saunders coupling value. For today's lecture, we will discuss a high spin and low spin ground state term symbols of Fe3+. So we know the atomic number of iron is 26. So in Fe3+, the total number of electrons will be 23. So it will be a configuration like argon D5. So for low spin complex such as ferricyanide, the electrons can be distributed as whereas in high spin complex such as hexaquo iron 3+, the electrons can be distributed as at the highest spin multiplicity following Hund's rule. Now for low spin system, we have to determine the number of S, which is the total spin quantum number. Here two electrons are paired, so total spin quantum number will be 3 into half plus 2 into minus half, because 3 electrons are in positive spin and 2 of them are in negative spin. The resultant spin quantum number is half. So spin multiplicity 2s plus 1 is 2. Now for determining L, we have to calculate the total magnetic quantum number. So for Eg and T2g, we can assign the magnetic quantum numbers as plus 2, plus 1, 0, minus 1, minus 2. So checking how many electrons are in which magnetic quantum state, we can calculate the total magnetic quantum number. So in this case, it is 2 electrons are in plus 2, 2 are in plus 1, 1 is in 0. So total angular momentum is 4 plus 2, 6. Now for angular momentum values, we have 6, so I have written up to 6. The value of L, the notation of L is S, P, D, F, G, H, I. So for this case, Fe3 plus low spin, L will be I, because 6 is the total magnetic, the total angular momentum. So here L equals to I, and J stands for the RS coupling. If any orbital is half filled or full filled, J equals to L. If it is less than half filled, J equals to L minus S. It is more than half filled, J equals to L plus S. So here we have 5 electrons in a 3D orbital. So it is half filled. So J will be equals to L value or equal to 6. So the ground state term symbol for Ap3 plus low spin will be 2s plus 1 was 2, L was I, and J is 6. The ground state term symbol of Ap3 plus low spin is 2I6. Coming to the other part, which is high spin Fe3 plus, we can arrange the 5 electrons into T2G and EG following Hund's rule, where we will get the maximum spin multiplicity following similar rules which helped us determine the low spin ground state symbol. Here the total spin quantum number is 5 into half, because there are 5 electrons, all are in same spin, positive spin. The total spin quantum number is 5 by 2. So the spin multiplicity is 2s plus 1 equal to 6. Here the value of L we determine similarly, plus 1, 0, minus 1, minus 2. So here we have 1 electron in each of those orbitals. The total angular momentum is to 0. So 0 stands for S. So the ground state term symbol is 6s, as it is half filled. Each has 1 electron. So the value of J will be L. L is 0. So the ground state term symbol for high spin Fe3 plus is 6s 0.